You're listening to the Chorus One podcast, a show that covers decentralized networks and their impact on the evolution of automated and borderless economies. On this podcast, we invite pioneers and builders to discuss the decentralized protocols and projects they are working on. On the show today, we have Bijan Sharohki, Head of Product, and Brandon Case, Head of Product Engineering from O1 Labs, the development company working on Mina. Mina is the first protocol to use recursive zero-knowledge proofs to track the entire state of a blockchain. Using zero-knowledge proofs to track states rather than a full ledger of transactions, Mina is able to keep their blockchain to a fixed size of 22 kilobytes. Mina enables a new category of applications called Snarkified Applications, or snaps. Snaps get executed once by developers, and thereafter nodes verify associated snark proofs, making these new types of applications highly scalable on Mina's recursive blockchain. Snaps are going live on testnet by the end of 2021, so we caught up with Brandon and Bijan to discuss what problems snaps can solve that dApps as they exist today can't. The podcast forays into how Mina snarks can be used as a bridging tool, the dynamics of their Snarketplace and future Mina scaling solutions, plus so much more.
Hi, and welcome to another episode of the Chorus One podcast with your hosts Felix and Xavier. Today we have two guests on from O1 Labs, Bijan and Brandon, working on Mina. Hi guys, welcome to the podcast.
Hello.
Hi.
Maybe, before we get started with questions around Mina and what you're working on there, it would be helpful for our guests to hear like an introduction to both of you. So maybe Brandon, can you start?
Sure. Yeah. So forgive me, my introduction is always a little awkward, but so I'm the I'm the first engineer at O1 Labs. So I like to call myself that because it's hard to kind of pick one role for me. So I've done a bunch of engineering work around the protocol early on. I did some product work, product engineering, some DevRel, and now I'm working a lot on snaps, different pieces of snaps. So, and you may have seen me in like marketing videos on YouTube and stuff. So, yeah, I don't know. Bijan, go ahead.
Sure, yeah. So I'm Bijan, and I'm head of product at O1 Labs, and so my biggest area of focus right now as the product team is the area of snaps, and that's what we're focused on right now as a whole team.
Yeah, thank you very much for the intros, guys. So, and that's one of the key things, I guess, that we're going to try and dig into a bit more today, which is the keyword of snaps. But I think so maybe for other Chorus One podcast listeners that could have heard a little bit about your network before, when you used to be called Coda a year and a half ago when we first had you on the show. So a bit's changed since then. You're now called Mina, but maybe it might be a good chance to just take a refresher into sort of
For sure.
Mina
I'd be happy to explain that. So Mina is a lightweight blockchain that is really built for mass usage of the protocol. And let me explain to you what I mean by that. In a world where there are billions of people that are connected to a blockchain, there are a few problems that will emerge. So one of those problems is that the size of the data continues growing. So that becomes a big issue from a scalability perspective. It gets pretty tricky to figure out how do you use data in a way that is private to the person who owns the data and at the same time usable to the other sides, the other parties in the ecosystem. And there are also decentralization challenges. Like, how do you ensure the network remains decentralized while there are a large number of participants in the network? So Mina has really been built for addressing those problems using the novel technology of recursive snarks. It basically allows the blockchain to maintain a size of less than 22 kilobyte which means that it could be available from any device that can basically have 22 kilobyte of storage, and that's really important. So Mina is really trying to use this new technology, recursive SNARK, to build a protocol that can be scaled and have a really good path to scalability in various areas in the long run. And we do that through the usage of ZK snarks.
Yeah, I guess. No, yeah.
So I guess, sorry, Felix, to cut you off. I think might be a great sort of time to ask you about then. Yeah, so what are these recursive snarks, and how they? I guess it's very different to what other networks that we typically have on the podcast. So it'd be great to sort of hear on a high level what this is, maybe for listeners who might not be as familiar with it as well.
Right. So a zero knowledge. I guess we should start with a zero knowledge proof. Just briefly. Probably your listeners have heard about this many times, but let's see. I guess maybe a concise explanation. A zero knowledge proof is or in this case, a snark, an argument, is one where you can prove to someone or make a convincing argument to someone that you know something without revealing any information about like what it is. So there's a cool metaphor with Where's Waldo, where you take like the Where's Waldo book and you put it under a piece of construction paper. You can show someone that you know where Waldo is without revealing to anyone else if they see the book later, to find Waldo. So so that's like zero knowledge proofs in general. Snarks, ZK snark, it stands for zero knowledge, succinct, non-interactive argument of knowledge. So the zero knowledge bit we talked about. Succinct means that these proofs are really small and very cheap to verify. So no matter how big, how complicated your argument is, the proofs remain small. So and I'll just skim over the other bits because I'm ranting. So why is this different from other proof systems? So Mina's snark in particular, it has, I'd say, like three interesting components to it. One is that it's universal. So this means that, and this is new from the last time we spoke. This was a later addition to Mina. So what this means is the circuit that the snark is based on, basically like what sorts of things we can prove, can change, and moreover, it supports recursion. So this is what gets us the small blockchain. But the recursiveness combined with the universality gives us snaps. So we, like, users can write snaps by part of which is writing a zero knowledge proof circuit, and that can be folded into the main blockchain proof of Mina. And one more thing, there's no trusted setup, there's no toxic waste, unlike other snarks. So we don't have to trust that people did the right thing. We can just trust in the cryptography. So anyway, I can keep talking forever on this. But,
thanks so much for that. I think you already dropped a bunch of keywords again, the snaps. I think maybe it's also now a good time to go into what are snaps, maybe in what, since it's, I'm assuming, right, it comes from applications, so maybe like also talking a little bit about how can people develop snaps.
Yeah, sure. I'd be happy to share with you what snaps are, and then we can kind of go from there. So let's first talk about the problem that exists today, right? Today, in order for you to share a piece of information, you have to reveal that information, right? And what that means is data really exists in like kind of this binary matter of it exists or it doesn't exist. There's no concept of like fractionalizing data or just like revealing part of the data that's very relevant. Like you just have to kind of reveal that truth. Whereas if you could live in a world where you could only reveal a particular characteristic about a piece of data without revealing the actual data itself, all of a sudden it gets a lot more possible to share more information with people because you don't have to worry so much about revealing the actual piece of information itself. So, for example, let's say that I wanted to get into a bar, right? And I don't want to share my personal address. I don't want to share my date of birth. I don't want to share everything about myself. I can only prove that I'm over the age of 21, right? And this is a really good example that could really apply to so many other things. It could apply to the medical industry where people don't feel comfortable about sharing information about themselves publicly with different consumers of information. It could apply to the financial industry where people don't feel comfortable sharing everything about their financial status with different financial institutions. It's basically this whole idea that you're actually today not able to um, basically share a characteristic of your information without revealing the whole thing. So how do snaps and snarks basically solve that? So um, snaps are basically snark powered applications, and what it means is that it enables decentralized apps that I believe your audience is pretty familiar with what they are, to have privacy preserving characteristics, which means that it'll allow people to basically do some sort of a computation, generate a proof of that computation, and submit that proof publicly, and then have anybody to verify that. And what this means is that now, instead of you having to reveal that information, or even having reveal that information, let's say in the world of Ethereum, have everybody in the network to verify it, you're able to use your own computation resources to generate the proof, submit that proof to the chain, and have people that want to verify it to verify it. This basically makes the system a lot more efficient. It's a lot more scalable rather than expecting that everybody shares everything. You're only revealing what's necessary. And rather than expecting everybody to participate in the computation, you're the one who's doing the computation. You're submitting the proof of that computation to the chain and use that. And that computation could be basically generating proof of that characteristic. So, for example, it could be that I'm going to generate a proof using computation that your credit score is over 700. And I'm going to just submit a proof that your credit score is over 700. And anybody can verify that piece of proof. So snaps are basically this vehicle that enables you to generate proofs of any computation, submit it into the chain, and allow the world to use that verification for their purposes.
Okay, and so thank you for the explanation. I think it's definitely very unique compared to what exists today, and so like Snaps itself, like Snark applications, it's quite in a way borrowed from on Ethereum you have decentralized applications, and so I'm interested to hear with Snap. So what are some typical types of use cases that someone would use a Snap for over say like a dApp on Ethereum, for example?
So that's a very good question. There's so many different actually unique use cases that you can think about here. So if I wanted to kind of really actually focus on today's world of like where we are with crypto, DeFi applications, DeFi would be very excited about that because today the challenge with DeFi is that you're only able to use Web3 data, and that really limits your hands. Whereas majority of data in reality still lives in the world of Web 2. So with Mina, you're able to all of a sudden basically get access to private data that lives in Web 2 and basically kind of unlock the power of DeFi. A good example that I can mention, and maybe we'll get to talk a little bit more about later, is that one of our first proof of concept partners was Teller Finance that we've been working with. And what Teller Finance is doing is they're providing non-collateralized loans. And in order for you to have high confidence in your non-collateralized loan to be paid back, you need basically all kinds of creative ways to verify that somebody is creditworthy. And Mina can solve that problem. Mina can, for example, prove that somebody's credit score in the Web2 world is higher than a certain threshold that makes Teller Finance, let's say, comfortable with releasing that loan, so that they know that the money will come back. So there are a lot of interesting use cases. Like we published an article that kind of goes over many of these use cases, but we can talk a little bit about, for example, identity verification as one of the areas that are very interesting. um, identity ver- Identity verification has kind of been I would say one of the like a key frictions in adoption of a lot of internet technologies in general, because people just don't feel comfortable with sharing information. They've had a lot of bad experiences with previous uh, companies that came in. They owned the data and they used it for their own purposes. We think that in the world of DAOs, it'll be pretty interesting. Like there are so many interesting things that you can do in the world of DAOs in terms of like whether it's private voting or like participating in certain activities that are being done in the ecosystem. You can think about it as other areas such as proof of ad spend. We thought is pretty interesting. Like today, one of the challenges in the industry of the ads space is that people do take advantage, and they say that, oh, we showed your ad to people in this demographic. And there's no way for you to know whether or not that's true. In fact, some advertisers are known to say that, yes, we do have a bidding system, but what they do is they have internal departments participating in that bidding war to kind of jack up the price. These are all kinds of problems that exist today that there's no way for an advertising client to avoid kind of become a victim of that. And we think that with verification of private computation, we're able to address a lot of these problems.
So I guess when I think about that specific one with identity and also the ad sort of use case, I feel like a lot of Mina's use cases are very like real world applications of blockchain that potentially haven't been tapped into as much, which is like I think quite exciting to see. Sort of like you said with DeFi as well, the uncollateralized loans, for example, it's like bringing some off chain concepts sort of on chain. And maybe we'll talk about in a second, how you're sort of distributing that information, let's say, to your own chain and also to other chains. But I do have actually sort of a follow-up question to this ad sort of use case, which I haven't thought about before. And also, you could also think about this for maybe like a social media company, for example, like even like a Facebook or someone. So I guess if I have my credentials on something like Facebook or some social media platform, and then I want to prove I've got a Facebook account, let's say on Mina. So would there ever be a time where I guess some of these Web2 companies like your Facebooks, etc., like they will charge me to prove this on Mina? Like will they figure it out at some stage, for example, or is there a way around
so
that?
what's really interesting about snaps, we can pull in data from Web2 data sources. Think like REST APIs or GraphQL APIs, things like that, that are like already exposed, because they're signed with HTTPS, TLS certificates. We can bring in that information into the SNARK without that company or service or product even being aware of Mina. So we think that's like super powerful. So like in that particular example, like you can because you're the one that's actually executing constructing the proof, executing the program on your machine before you submit it to the chain. You pull in your data using your authentication information, your keys, your OAuth token, whatever, with Facebook, let's say. You're pulling in your data, you're constructing a proof that exposes only the pieces of the data that you care about, only the like computed view of the data that you care about, and then you submit that to the chain.
And so let's say in the same example that I have like OAuth credentials or something, and I want to prove something to like an application or something on chain in the Web3 world. So with these credentials, are they sort of being, I don't know, like in terms of the incentives for, so let's say it's me and I want to prove something to a Web3 application, do I have to do this myself, I guess? So like, what does the sort of user flow look like? Or is this something that the application in the Web3 world like covers for me? Or is that complex at
So
all?
it's well, it's up to the application developers, I suppose. But the flow that we imagine, the typical flow is, so a Snap developer will make some application, and there's a button that's like, okay, like connect my my Facebook data or through OAuth button. So you press that, and then you go through the user. You go through the same web flow that you normally go through whenever you're sort of connecting some OAuth application. So you say like, is this me? Sign in as me, whatever. This application wants to get this and this and this. The one extra step is typically you'll be setting up your own API key because with the service, because you're essentially hosting your own application, because the data from Facebook isn't going to the third party typically. I suppose some, like, you could set that up, but typically, like, you want the data to go to you. So you need to register for keys, and you need to OAuth with yourself, and then like that the Snap developer would set up an application that sort of like connects all the data, all the plumbing for you, so you don't have to write any code, obviously, as a user. Go ahead.
No, I was just going to ask: is someone already working on building this sort of application for the user already? Is that something that Mina itself is building, or someone community person is building out to make that process easy?
Well, it's something that O1 Labs we're working on. This we're calling, I guess it's a working title, Snarky.js, our developer toolkit for snaps. So part of this we'll have at least one. So we already have it almost done, but we'll have several examples that sort of do this, and we intend on building some like reusable gadgets to sort of make it easy to build these kind of flows. But it's different for the different sorts of data sources, right? So like if you're getting data from the Binance Binance trade history data, the way that you access that information is different from Facebook data, or I'm blanking, Google Calendar,
No, I think it's very interesting. I guess it's sort of like using Mina, you can choose to show what you want. I guess if it's your Binance trading history, if it's your Facebook credentials. I'm not sure if that's like a one-stop shop you can create yourself and sort of customize. But I think I did have a question. Just want to take it back a little bit to the sort of information side, and how Mina does act as this like real world sort of on-chain connector. So I've seen a little bit. So we have Chainlink, that's like an oracle that's been quite successful in the blockchain world for a while now. So in some ways, I sort of see Mina can act as an oracle in some circumstances. So is there a lot of difference between like what Chainlink does versus what Mina does for this sort of scenario?
Yeah, there is. So good question. And so first of all, I would say that Chainlink is like really focused on public data, and we're focused on private data, and it's very different. I think what's maybe worth like kind of discussing a little bit is like the role of oracles, because Chainlink is really built using the oracle concept. And in Mina, we don't really need oracles because everything is cryptographically proven, right? That's one of the interesting things about our protocol, and we basically eliminate the need because the data gets passed from Web 2 to Web 3 through HTTPS, and it can be done in a trustless way. And in a way, we can say that the entire Mina network becomes maybe a trustless Oracle system for the rest of the crypto ecosystem. So I would say we're pretty different, and we're like really solving different problems. And because data between Web 2 and Web 3 are basically going from Web 2 to Web 3 through HTTPS is trustless, if you want to think of us as an Oracle system, it's a trustless Oracle system.
It's a good explanation, I think. Thank you for that. So there was also another sort of follow-up to that. I was reading an article recently. That would be great to hear sort of your explanation of. So we've talked a lot about off-chain data and sort of proving that and verifying that on-chain. So I read that Mina could theoretically validate Web3 data from any blockchain using Snap. So I'd love to hear sort of your insight into how that's possible.
Yeah,
with Mina.
sure. There's actually different ways to do this. This is pretty interesting. You can use web snaps to actually consume the Web3 data. That's one way to do it. That would be pretty straightforward. We can use something like Graph Protocol down the road to use that information that exists in Web3. And another one that is kind of like more traditional, which a lot of projects are doing, is like really building the bridges between them. So different options are there, and it really depends on like kind of the particular chain and like what the use cases are. But there are ways for Mina to consume all that information.
I think heading towards a sort of strategic area now for Chorus, because we're sort of bridge builders ourselves. So we might hop into that a little bit now. So yeah, I guess so. There's been some news recently since we last spoke that you're sort of bridging to Polygon, for example, when you've got a relationship with Ethereum. And as you just mentioned, you can sort of quite easy. You make it easy to bridge between chains, I'd say, and it's a hot topic right now, interoperability. So yeah, it's just I think it'd be great to sort of hear like how Mina is such an efficient way to sort of bridge between chains.
Yeah. So yes. So let me just paint the picture or set the stage. So like Mina is powered by the succinct blockchain. I guess we haven't really touched on this too much in this call yet. So what this means is the whole blockchain is less than 22 kilobytes. Bijan mentioned it. And there's a single snark that proves that the state is valid. And every time we add a new block, we essentially we fold the proof into itself, and we have another proof that proves the whole chain and that new block. So we always have a single snark, and we always have state that's small. So the cool thing about that is the state can just fit on chain. So like the way the Ethereum bridge, the way that the RFP sort of sets it up, and that there's a blog post by the NIL Foundation about how they're working on this. We just have the whole state of Mina like in Ethereum, and with a like moderately reasonable amount of gas can just verify the snark. And so it's super cool. So it's sort of you have full access to the full chain in other protocols. And this is like well, sorry, I'll leave it there. Any follow-ups there? Yeah.
I think I'm sure Felix has one or two, but I think an immediate one for me is this sort of, I mean, we've had a lot of interoperability networks on recently, like this Axelar and Wormhole, etc. So I guess like the proof of the state of the chain, like you said with Ethereum, for example. So it's just like in the Cosmos ecosystem, we have a lot of Cosmos chains on, and it's sort of like clients, and it's like trustless, like bridging almost. Can Mina act in any way? Like you use a Mina proof of the state of some chain, basically, in like a light client to connect two chains, or is there different ways of sort of bridging the two chains using Mina, or is it always the same? Just like here's one state, and this transaction happened, for example.
Yeah, I think so. So that's sort of the other side, the other side of the bridge. So one side of the bridge is like Mina's state just lives on the other chain, and we can in the smart contract on that chain verify the snark. And then on the other side is like put the consensus logic for the other chain. Encode that in a snark circuit and fold that into Mina's snark, and that's also something that is possible that we haven't implemented yet, or there hasn't been an implementation of yet. But that's sort of that's how we're thinking about how the bridge on the other side works, and yeah, so the I actually haven't thought. I'm sure someone, maybe Bijan knows, or I'm sure someone at the foundation has thought about this, but I haven't thought somehow leveraging this for connecting two chains to each other through Mina, beyond just like, here's these, chain A connects to Mina, chain B connects to Mina, and then you can sort of talk through them. But I imagine, I don't know, someone would have to think about it carefully, but like, there's probably something there where you can kind of connect them directly as well.
Yeah, definitely.
Yeah, I think Mina Foundation did pay a little bit of an attention to this, but we haven't on our side so much. Mina Foundation is kind of like more focused on growing the whole ecosystem by enabling all these bridges and connections between different chains to Mina and vice versa. So I think they're the better people to answer this, but I'm sure they're working on this or thinking about it.
Yeah, I mean, the one thing that's really exciting though, for OAuth Labs in this context of snaps is like these bridges let other chains take advantage of the features of snaps, like the stuff that Bijan talked about, like being able to reveal, that we've all talked about multiple times, but being able to reveal like computed views on your private data. Like when the Ethereum bridge is in place, like you can do that in an Ethereum dApp, which is like super exciting, and we're going to make sure that the tooling that we're working so hard to make usable will be nice to let folks.
Maybe we can also like cover a little bit where, like, I guess we already discussed now theoretically a lot how this will work. Maybe you can share a little bit of where this is at right now. Kind of, when do you expect to release the Snarky.js? Are people already using it to build stuff? Kind of like some information.
Yeah. So everything's open source. If you go to, I think it's either Mina protocol /Snarky.js or OAuth/Snarky.js. I don't remember. But we have a Snarky.js repo. We pulled it out of our mono repo, so it's a separate repository on GitHub. It's being actively developed. So anyone can just go right now. You can now currently the main branch is good. For a while you had to know which like secret branches by accident, just because we were working off of random branches. But now the main branch is good. You can pull that. You can run the examples that we have. Yes. So it is in a state where you can prove snarks and verify them in the browser or in Node.js, and we have like some very small examples. We're working on some more polished examples. We have one that is, let's say, a few weeks to a month or 2 or 3, depending on how we prioritize it, away. And yeah, we're just working hard, like iterating on the SDK, like, and dog fooding it. And it's hard to say. Well, basically, when Snaps launches, when the protocol supports Snaps, we will have a release of Snarky.js that we're happy with. But it's like, it's one of those things that we can just keep working on forever and just make better and better and better and better. And that's what we plan on doing. And it's about like getting something in the hands of someone as quickly as possible. We already have, actually. We've already like workshopped pieces of it with different people, learning from them, going back, making changes, doing it again, repeating over and over and over and over again. And that's how we make tools that make people happy. So
I'm sure it's probably quite hard to get right the timing of how much you iterate on like the perfection of it versus sort of like the amount of demand I'm sure it has in trying to please everyone with, with like getting it out. So I'm sure it's a tough thing to balance. I wanted to ask a question actually sort of related to snaps, and so normally on other blockchains. Maybe a decentralized application you pay with fees, for example. So in Mina, we haven't really touched upon it in this podcast, but maybe for a little bit we can. So what's really unique about Mina is you have like a user, like any one of us, we're using a snap, let's say, so we'll pay a fee to use this snap, and then there's another party called a snarker, which is someone that's actually doing the computation, basically, that the user would pay the snarker. So there's almost like an intermediary between the user and someone like Chorus One, and we're a validator. And so this second party, let's say the snarker, so what is a snarker? And there's also another concept that I really love called the Snarketplace in Mina. So I think that's really cool, and sort of like it's hard to see the potential of this so far because snaps aren't live yet, so there's not as much activity as what there will be in the future. But yeah, what do you guys think of like the Snarketplace and the role of the snarker?
Snarketplace is such a cool term. It just sounds cool. It's just snark and marketplace like smashed together. So it's a snark marketplace. So there's so as you're saying, there's really like three parties at play here. There's the user who's trying to send a transaction, and this is on mainnet right now, payments or delegations. But when snaps are released, also snaps like fit into this. So I guess like the snaps may be like more computationally intense than like a payment, depending on what the application is doing. Remember, it is not too computationally expensive because the proving is being done on the user's computer, but you can do fancy things like chaining multiple proofs together. So essentially, like we just break that into a bunch of pieces. So just think of it like we have a bag of transactions. Okay. So the validator makes blocks, and alongside we call them block producers. So the block producer makes a block, and with the block they need to create the new proof that proves the whole state of the chain. And making these snark proofs is somewhat expensive but reasonable for validators. But what would be unreasonable is requiring validators to make snark proofs for all the individual transactions inside the blocks. And that's why we have to introduce this separate actor, just because it's like infeasible to require that. You would need a crazy amount of computational power, and that's sort of antithetical to one of the goals of Mina, which is like to keep it as decentralized as possible, keep the network as decentralized as possible. So right, so we have the snarker or the snark worker. So the snark worker takes the transactions that users want to send, they create the proofs, and then the block producer, they get to buy the proofs that are already done for the snark work, and sort of include those in the block in proportion to the amount of new transactions they're adding. So it's kind of hard to visualize this, but you can think of it like you have like it's a fixed buffer essentially. So you can think of it like a shelf, and your shelf is always full with a mixture of proofs and transactions, basically. Like proved transactions and unproved transactions. Whenever you're creating a block as a validator, you want to include as many transactions as you can, because you're going to get the transaction fees for those transactions. So you're incentivized to put transactions in the block. But the protocol requires that whenever you want to add something to the shelf, when you add a transaction to the shelf, you have to take something off the shelf. You have to take a transaction off the shelf and replace it with a proof. And where you get the proof, well, you buy it from a snarker. So you collect the fees, or rather you pay the snarker for a snark. You'll pay less than the amount that it takes to that you're earning from the transaction that you're adding, and then everyone makes money.
And this transaction fees, that's basically, is there like something in the protocol that determines them, or is the validator kind of setting the transaction fees to account for the stuff he has to pay to the snarker?
Yeah. So yeah, it's the same as any typical network. So it's like whatever the market decides should happen. And something that's super interesting that we did not expect to happen. I didn't expect it. There were people who expected it probably, but is right now most of the snarks on the network are sold for free. So nodes are performing the snarkers on the network are providing these snarks altruistically, and then validators are able to buy them for free, and then are therefore able to accept transactions with extremely low fees. Will this always happen? I don't know. We'll see what the
as long as you keep running your free snarker.
Right. So what's happening is validators they want the network to succeed, and they want to push transaction fees down because they want people to use the network. And to me, it's kind of like it's kind of the same as like if you think about it, like what motivates anyone to accept transactions on like the Bitcoin network, like you're when you send your transaction out, like there's someone who's making a block, or rather like you're sending it to a relayer that then like sends it to the gossip net. And like why is the relayer relaying your transaction? Like you're not paying them, they're not earning any transaction fees for doing that. Only the node that actually mines the block like really earns anything. So but they do it. So it's kind of like it's just a weird, like rational something.
Yeah.
So yeah. Any questions about this, or did I get the right? We have a cool
it has a good visualization.
A visualization.
So we should share that, and also the links you mentioned earlier that will make it a bunch clearer. I think also. Yeah, it's super interesting. I mean, it will probably change a lot too once there's now snaps. And I guess, I don't know, maybe you can also share what you expect. Let's say there would be demand for transactions similar to some networks that exist. Would it mean there need to be like a lot of snarkers out there to kind of keep up with the snarking? Or did you do any like simulations there?
Yeah, so there's an interesting like relationship between the capacity for throughput and latency. So, well, this capacity, what is actually there, and latency. So like if we increase throughput, like if we increase the capacity for throughput, but there isn't that throughput, but like transactions and things are just trickling in very slowly, then latency goes way up, just by the nature of how the proofs like form together. If we so it's sort of like in the best interest of the protocol to keep the throughput maxed. So in this world where we are now, we don't have like too much network activity, and so like the capacity for throughput isn't too large, and this is like this is on purpose. And there's Evan has talked about this. We have all these plans for there are some things on like the engineering side we need to do to increase when throughput gets to a certain point, but yeah, like when we see snaps, we may want to increase that throughput. What we expect though is like, we don't want to spend effort where it's not needed. So like we would rather put all of our effort into like delivering snaps in the best way possible, than like spending a ton of time increasing throughput before we even have a product that people want to use. You know what I mean?
And I might sort of ask one last question maybe before we think about wrapping it up. Sort of on this topic as well. So the throughput topic and scalability and scaling blockchain. So these days there are so many solutions like layer 2s on Ethereum and also some layer 1s in the wider ecosystem, like Terra or Solana or other networks like that. So you said something interesting before, which I think would be cool to sort of dig into a little bit further now, which is, so let's say Mina has all these snaps and throughput, like an Ethereum layer 1, for example, where eventually it reaches this limit where, there's just so much activity going on. Maybe there's people bidding up transaction fees. So is there a way like you said that I guess Mina can be an L2 of the other chain. You said it a bit earlier. I'm not even sure how to phrase this question properly. But is there like some way that Mina can scale with like a layer 2 level almost?
Yeah. So this is something that the foundation's thinking about. And not something that anyone has started implementing. But yeah, like the I guess it's just what you said. Like there can be like it's like it's a little fuzzy in my head. It's less fuzzy in other people's heads. But like essentially, we can have an instant finality, quick, high throughput, a little bit less decentralized L2 that sits on top of Mina and sort of and periodically like checkpoints, and that can be used to dramatically increase capacity if it's necessary, and that so that can live on Mina directly, or that can be sort of also facilitated through a bridge, right? Like that sort of layer 2 can be some other protocol that's sort of tuned for that, that has made those sorts of trade-offs, and then like periodically be like checkpointing back to Mina. And in the same way, like Mina can be the layer 2 that adds this sort of like extra computational ability to those other chains, by like letting them sort of use those features of snaps. So that's in my mind how it's like they're layer 2s for each other.
No, I think it's so cool. I think, to be honest, like the possibilities of what you can do on either side. I want to thank you both so much for your time today. I think you've given such a great in-depth explanation into what snaps are, what's possible with Mina. I think at Chorus One we're super excited to see snaps go live, but it's also been awesome to see how like great you've been doing since you went live, with Genesis and Mainnet. So yeah, we're super keen to see where you go in the near future, and hopefully we can have you on at some stage later on to talk about how it all went. Oh, actually, one thing I will mention, maybe might be a good time to sort of, if you don't mind, maybe drop your own socials and maybe where people can find Mina itself if they want to learn more about Mina.
Sure, I'll go first. So I'm at bcase_, BKASE_ on Twitter. And you can also, you can find me on Discord, on the Mina Protocol Discord server. So I guess you could go to the Mina Protocol Discord server. You can follow Mina Protocol on Twitter. You can follow OAuth Labs on Twitter. You can go to OAuth Labs on GitHub or Mina Protocol on GitHub. And we also have a subreddit. I don't know. And I'll let Bijan. Actually, one thing that I think I just forgot to mention, but meant to when we were talking about the Snaps developer toolkit, that I just think is really important. Snaps are built using TypeScript and JavaScript. So to my knowledge, this is the only zero knowledge proof like toolkit that is fully in in a programming language that people are already familiar with, like general Web 2 developers are already familiar with, and Web 3 developers. So this was like a really, really important, like very carefully thought out design decision that we made early on. So by doing this, we leverage all the tooling that already exists for TypeScript, and it sort of gives us a shortcut. So we can focus on the tools that we need to build and the tools that already exist, that already have millions of hours of engineering effort in are there. So I just wanted to leave with that as well. Okay, Bijan, go ahead.
Sure. Like my Twitter handle is Bijan_SHA, so BIJN_SHA. I think the rest of the companies, the O1 Labs and Mina protocols, like social media handles, Brandon already mentioned them. One thing I will add is that we have an upcoming testnet and workshop and hackathon very soon. So For those of you that are interested, highly advise you to either follow Mina Protocol on Twitter or sign up to the newsletter on minaprotocol.com so you can be informed when we're ready to do that testnet and the workshop and the hackathon. It's going to be fun.
Sounds great. I'm sure we'll be keeping a keen eye on what's going on there as well. So, yeah, from Felix and I both, thanks so much for coming on the show today. And yeah, we'll hope to catch you again soon.